Hi, everyone. Good morning, good afternoon, good day, wherever you're dialing in from. We'll go ahead and get started shortly, just to allow for more folks to join before we kick off. And good morning to those who have just joined. We'll wait maybe up to 30 seconds more before we kick off. Thanks for joining. All right, we will go ahead and get started. Hi, everyone. Good morning, good afternoon, and welcome to today's NASA SBIR Ignite Ask Me Anything, focused on the AI subtopic, multidisciplinary space hardware design automation, leveraging AI techniques. I'm Beth Facareza, and I'm part of the NASA SBIR Ignite team through my work at BMNT. We help startups navigate through Ignite and unlock commercial opportunities, both in space and here terrestrially. Before we dive in, just a few quick housekeeping notes. This session is being recorded and will be posted on the Ignite website afterward. Please do use the Q&A box to submit your questions. Upvote the ones that you want answered, and we will do our best to get as many, hopefully all, answered as we can. We'll also be launching a few quick polls during the session. Your input on these polls helps us tailor these sessions to you, so please do jump in. And lastly, if you missed Tuesday's Ask Me Anything session, Keys to a Winning Ignite proposal, the recording will be available on the Ignite website soon. That session covered the proposal process, award structure, and lessons learned from past winners. So it's a great resource to get up to speed. You'll also find the full solicitation and other resources on the Ignite site. So now we'll turn it over to Haley Dowd, NASA's Ignite lead, to give a quick refresher on Ignite before we dive into today's subtopic. So Haley.
Thanks, Beth. And I just want to say again, thank you so much for joining and taking the time today to learn about this subtopic and hopefully ask some really good questions about how we're using artificial intelligence and how we would like your help. Next slide. So I'm just going to give a quick overview of Ignite in case you haven't learned about this funding opportunity previously. Like Beth said, there is a much deeper dive on this topic that will be uploaded to our website really soon that has a recording of the session. So if you want more details, you can always go there to look at a little bit more. So first, I just kind of want to discuss what makes NASA SBIR Ignite different than our traditional SBIR opportunity that's offered at NASA. I'm going to kind of assume that everybody has a basic understanding of SBIR. And if you don't, you can always go to our website and learn about our mainline solicitation as well as this solicitation. But for NASA Ignite, we are really focusing on commercialization. We are interested in technologies that will be able to enter the commercial market in like 3 to 5 years. We take that thought process through our entire solicitation development activity. So we have focused marketing that is related to commercialization. We design our topics and our proposal content to make sure that there is a market available in the area that we are interested in providing investment, and that we are getting the information from you as a small business to really understand what your go-to-market strategy is and evaluate that. So one of the big differentiators here is that for NASA mainline SBIR, most of those technologies are infused in the NASA projects and programs. And for Ignite, we are really looking for technologies that see their primary customer outside of NASA. NASA is interested in these technologies, but we really want you to be looking at other markets. Ignite has a much smaller cohort. So for mainline, we have about 250 awardees per year. in Ignite, that has ranged from 9 to 12 over the last 3 years while it was a pilot. And this year we're planning for 15. We also have a significant amount of entrepreneurial engagement during and after awards. So there's opportunities for interacting with NASA and our contractors through the process. One of the really interesting opportunities that we have prior to award is the opportunities to be involved in catalyst events that we hold to understand the market. So if you're not an Ignite awardee but want to get plugged in, that's a great way to do that. The other really unique thing about Ignite is the accelerated schedule. So we do have phase 2 proposals due at the end of the 4th month of your 6-month period of performance for your phase 1. And we really encourage you to propose a shorter phase 2 effort so that you can get to market as soon as possible. And we are implementing a new trial this year. So that phase 2 opportunity is actually part of an option in your phase 1 contract. So we're doing our very best to try to reduce any gap between phase 1 and phase 2 funding, because we've heard from you that that is a concern. Next slide, please. So if you've worked with NASA before, you've seen a similar slide to this. So what is really SBIR Ignite? What are the phases? What do those look like? So it matches mainline in terms of dollar amount. So phase 1 is $150,000 over 6 months. And then phase 2 is really for your prototype development. That's $850,000. And we say for a 24-month maximum. So we really suggest and recommend that you propose a shorter period of time there. You have available to you all of the same supporting opportunities that we would have with a traditional SBIR process at NASA. So you have the opportunity to apply to be involved in I-Corps, and you have the opportunity to apply for TABA funds as well. And then you're also eligible for all of our post-phase 2 opportunities. Some of these require matching funds so that we really understand that there are investors that are interested in this area and that can help support that last bit of development before you head to market. Next slide. So just quickly, dates that are important as we run through this cycle. You've already seen the topics as they've been pre-released on May 19th. The solicitation went live on Monday, June 2nd, and we are currently in the middle of our AMA series. So we do have 2 more next week. I'll talk about in just a second. Submissions are due on July 22nd at 5 p.m. Eastern time, and we'll expect to make award announcements in the fall of 2025 with a phase 1 period performance starting in early 2026. So make sure that you're taking your time now to make a good plan and start your submission, because we are using a new submission site this year. So make sure you leave yourself enough time to learn about that too. Next slide. All right, so we do have 2 more AMA sessions, one on June 10th related to advanced manufacturing and robotics, and one on June 12th about our radar topic. So please go to our website if you're interested in those and get registered for those as well. Next slide. And if you want to stay connected, or if you have looked through the Ignite subtopics and found that maybe this is not the right fit this time, but you want to keep watching our opportunities, please sign up for our newsletter so that you can learn every time that we have an opportunity released. Also, you can access the recordings for our AMAs on the SBIR Ignite website as well. If you want to get connected to the community that we are building, please check out the Slack channel that BMNT hosts. And if you found that NASA may not be the right fit for you, but you're still very interested in SBIR, please go to SBA's website to learn more about SBIR programs at other agencies, because there are tons of opportunities that span a broad range of technology areas. So please check those out too. Next slide. So I'm available if you have a couple of questions now.
So we have one question in the chat, Haley, which is, what is the submission to award rate for Ignite?
So we don't typically publish that information. It is a little more competitive than mainline, but you still have a very good chance of winning.
Thanks. And please do send your questions into the chat. And we, again, will make sure that we get them answered. So no further questions at this time, Haley, but we may circle back toward the end of the session.
Thanks, y'all.
Thank you. So now we will turn it over to Ryan McClelland, research engineer based at Goddard Space Flight Center, and one of the topic authors behind this AI-focused subtopic. So Ryan, over to you.
Okay, are we all set with audio, video, slides?
All set. We can hear and see.
Okay, so I'm going to talk about how we can revolutionize the aerospace industry and hardware design with AI. And there's been a lot of work in space with AI for autonomy and AI for looking at the vast sums of data that we return, but there hasn't been a lot of work for AI to develop hardware. And I think there's going to be a lot of commercial viability there. I'm going to start with just an example of what we've done here at Goddard with these kind of alien looking structures that you see, and then talk about how that led us to develop this sort of new paradigm in engineering that I think is going to be very powerful. So a couple years ago, this this headline was written about this work. NASA's NASA's generative AI builds spaceships, kind of throwing shade at LLMs, or their parts at least, which look like skeletons. And at the time, it seemed ridiculous that you could use a language to build spaceships. But now I think it's possible because our missions and really most design of products starts with a concise text description of what you're trying to build. So for our space missions, that might be the number of astronauts you need to get to what planet in what time frame. Or for a science mission, it might be what samples you have to return from what moon. And then after that text description and years or decades of work and the work of hundreds or thousands of people, you finally get that satellite on the launch pad. But I think with the massive benefits that AI gives us, we can shorten that by a factor of 10 and also get game-changing performance improvements and build that future that we all grew up with in sci-fi, dreaming of, where we have thousands of people living in space, we have space cowboys and all these amazing things that we want to see for ourselves. And by example, this is a traditional structure. It's a bracket that holds something for an aerospace application, and two of our top engineers in 2 days did 4 iterations, which is really fast for design and analysis at NASA. And we couldn't meet the performance and manufacturing requirements. But with our evolved structures technology, one engineer powered by AI in 1 hour can do over 100 iterations and come up with a structure that's lighter, stiffer, stronger, and easier to manufacture. And this is really a paradigm shift in what the engineer does. In traditional process, you have design requirements and goals, and then some kind of designer, an employee with a tool. In this case, we come up with a CAD model, computer aided design model, and throw it over the fence to an analyst who has another employee with another tool. And there's a back and forth there that may be strong or weak depending on their personalities and whether they're going on vacation or taking training. And then there's drawings, which is kind of another tool, and machinists, which is another tool. And this process, even for something relatively simple, can take months or years. And a more streamlined process with AI is the design requirements and goals come in to an AI system that generates the design, checks the requirements, and checks fabrication. So in this case, we've really narrowed down the number of employees and tools that are needed to do the job. And it refocuses the engineer on the higher level of abstraction, which is the requirements. And you'll see that as a theme as these AI systems develop. So we can now go from requirements to parts in hand in less than 48 hours with this technology. And we've even taken it a step further, and we're working on something called text to structure, where there's really now just a tool. So to develop structures, you just have this tool. On the left, you have a bunch of text inputs that come into it, a standardized set of inputs, and then it has a standardized set of outputs, things that people want for structures, FEA models, that's finite element analysis, or CAD models. And in this topic, we're looking at AI very broadly, like not just necessarily just Gen AI or ML, but any computer system that does something that normally requires human intelligence. And this is a definition of AI that came from Wikipedia in 2018. So it's a very the definition I know is always fast moving. And to give it another example, imagine text to telescope. So you have a lead agent who's like a digital employee, and they have a digital tool for requirements decomposition. And then those requirements go to other digital employees, agents that have tools. So the optical design agent might have a Python based reinforcement learning tool that develops the optic designs or picks components. And then an optomechanical design might have CAD tools and also knowledge about what optomechanical, how you support mirrors and lenses. And then an analysis agent can do the analysis. Then you have, harnessing. You might have some wires in this that the harnessing agent has to route automatically. And then a reporting agent that documents what was done and packages it up for the human engineer to look at. So I have this sort of, kind of terrible use of the eyes emoji here on the icon on the left. Uh, the human that's overseeing the process and making sure it stays on the rails. So I think, and I hope this idea is getting across. This is what we're really looking for. We're looking for those, digital employees and tools, and it's a different kind of tool that a agent, and I'm using digital employee maybe as an easier word of saying agent, that an agent can use. So if you think about the tools that we have now for hardware design, they're all based around mouse and keyboard, clicks and typing things in. But that's not how digital agents or digital employees are going to interact with tools. They're going to interact with APIs or something like model context protocol. So I think we're going to need different tools. Or maybe there are existing tools that have really good, already have really good APIs that we plug into. So we're really looking for these kind of tools and agentic systems that can automate the design of hardware. So, I think to successfully do this, you need to have someone who really sort of understands what AI is capable of today. And then you also need people who deeply understand how to deliver hardware. So, maybe, not just someone who maybe has a PhD in a certain topic, but someone who's also really, built things and delivered them. Because that is the knowledge that you need, I think, to build these tools that are going to provide value to NASA and to the industry more broadly in this, new engineering paradigm. So that was just an example to illustrate it. But we need these kind of tools and agents for everything. We need them for electronics boxes, solar arrays, thermal solutions, reaction wheels, uh, heat shields, communication systems, propulsion systems, everything that goes into a spacecraft. And I think if you can do this for a spacecraft, it's going to have really wide commercial applications for things that maybe aren't quite as complex, like a house. So, to talk a little bit about the role of the agents or digital employees, they convert our goals, what it is we want, into standard set of inputs. So each of these tools has to have a standard set of inputs. They help apply knowledge. So if you have standards or just knowledge that's specialized about how to build this system, they can apply that. They can apply common sense and intuition. So they'll do things like if you just have a flat plate and you're like, oh, where should I put the bolts? It'll give you like a good first round of where to put them. They can, and they, of course, orchestrate the automation tools. They communicate with other agents, and they help us interact with the outputs. And I think I could really fairly simply put this whole thing. They act as design collaborators with the things that the humans that are in the loop. So to put this really succinctly, we're trying to build multiplayer Jarvis for space systems. So if you've seen the Iron Man series, then it should be kind of immediately clear. And this will also help us accelerate the mission lifecycle. So at NASA, we generally do 4 really only four full iterations, phase A, phase B, phase C. And at the end of each iteration, everything is reviewed in a big document, and then we launch the mission. But this takes, years or decades because this is really complex, difficult work. And the hope here is that AI powered tools, we can do many more iterations and do them much faster. So instead of doing an iteration in, 6 months or a year, we can do an iteration in a month, an iteration in a week, and then review and launch much faster. So to conclude, there's really an opportunity here to embrace this new way of engineering and revolutionize hardware development. And it's both going to accelerate development and unlock game changing performance improvements because I think these are going to find solutions that people wouldn't, because a lot of times we have biases based on what we've seen before. And overall, accelerate our understanding of the universe. Okay. And final slide. I like this quote from Robert Goddard. There's a more complete recording of this that's a little older with this QR code, and this QR code here is my LinkedIn.
Excellent. Thanks, Ryan. A couple questions in the chat right now. Can you elaborate with examples, where able, where the commercial and NASA overlap exists for the AI segment, for AI segment applications in hardware?
Absolutely. So, in a way, the whole idea behind the text to spaceship vision is to align uh, the commercial tools and around like a broader vision. So it's all over, already kind of all over the place. So, for instance, in the text to structure, you see that we're using a commercial, like actually a couple different commercial tools. So there are a lot of commercial tools that are already being developed for these things. I don't know if you would want me to give name companies at this point, but I could.
I'll defer to Haley if that's a
Probably better to not, just so it doesn't look like we're, pronouncing some as better than others.
perfect. Thank you.
I would
Thanks.
say that both startups and incumbents are thinking a lot about this, but startups can traditionally move much faster.
What TRL should the AI be? What are you looking for in terms of stage development? Maturity, rather.
So I'd say I'm really looking for good ideas that can be rapidly brought into being. So uh maybe in like the three. I know TRL is very subjective. Definitely not six or above.
Great.
So I would
Thanks.
say more on the like innovative low TRL end.
Okay. What kind of outcome or demonstration is expected at the end of phase one? The topic description is wide open, so some clarity would be helpful where possible to provide.
Right. So I think we would really like to have. So let me put it this way. A lot of people don't believe that this is possible. So you talk to them about their subsystem, and they'll say you'll never automate the design of avionics, or you'll never automate the design of this. I think it should be a demonstration that's powerful enough to convince a lot of the skeptics. So the demonstration should provide a design and an output of a design and analysis that can help convince people that this is worth pursuing. So is it going to be solve all the edge cases in a specific hardware field? No. So if I were to give an example of a bracket or electronics, like you want to be able to choose some kind of simple application that has value and demonstrate that you can automate the design of it in a way that can become more and more generic over time. I hope that answers the question.
Um, for the person who submitted that question, if you do want more clarity, just go ahead and pop that into the chat, the Q&A box. Okay, a lot of the tools used currently in the state of the art for spacecraft design are commercial design tools that don't provide these API and have been built around optimized UIs. How do you see this changing? So there's a couple questions. So happy to repeat them, Ryan. So how do you see this changing? Do you believe in the plug-in approach or complete new redesign of tools, say the SolidWorks for AI versus an agent that works with SolidWorks?
So I'll say that a lot of the tools do have APIs, but a lot of the tools are older and they're CPU based rather than GPU based, so they're not very fast. And the way that I, personally see this going is that, tools that offer no API integration are not going to be, agent accessible, and they will over time see less usage because as you can spin up these digital employees very cheaply, they'll be able to use a lot of tools. And the engineering companies that embrace these tools are going to accelerate. So I think, yeah, it's really an incentive for any kind of incumbent to use APIs. But I know, like, some companies already have a lot of, APIs or Python interfaces for their tools. But the way that I see this going is when you have these agents that can use tools, it makes it easier to swap out tools. So maybe, we have these like very long tails in computer aided engineering where you start using one tool and then you're kind of like cornered into using it for decades, even as it loses relevance. I think what we're going to see with this agentic approach is you can swap out tools more easily so that you can use the latest tools, and then you'll have a validation set already, as part of this. And you say, oh, look, you know, we can use this validation set. This new tool gets us better results faster. We can switch to that new tool. So I think that answers the questions.
Thank you. Just to read out one comment from one of our NASA colleagues on the line. NASA has a lot of open source tools, which are also evolving. So probably more to come and more to see with that.
Absolutely, would love to see open source, and I think this actually can be a forcing function to have more open source tools, more and better open source tools.
Next question, and perhaps Haley can shed light on this as well. So if we are developing these AI tools in-house for our own engineering process, do we need to commercialize these tools to be eligible, excuse me, for the Ignite program? Or can we be using the tools to develop hardware that we can commercialize?
So the SBIR Ignite opportunity is really focused on investing in technologies that will go to commercial market. So I would say read through the specific language in the solicitation that it describes the intent and make sure that you're aligning to that.
Great, thanks. What is the end target TRL level? So perhaps a bit similar to a previous question, in which case we can answer from a Ignite perspective as opposed strictly to the AI perspective, if that's helpful.
Yeah. From an Ignite perspective, I don't like to call out like a starting TRL because it varies pretty significantly. But the aim of Ignite is to have fairly high TRL at the end of the phase 2. So we would hope to get to like a 6+.
Great, thank you. So the next question that came in it says two-part question. Please elaborate that implicit usage of LLMs is allowed.
Yes. So, yes.
Great. Do we need the underlying model that may assist to be housed offline? I can imagine, for example, using any APIs may break ITAR laws, for example, DeepSeek.
So don't use DeepSeek. Right. but the other, the major commercial models, we do have access to uh, Claude, um, OpenAI models, some and Llama, of course. So and we have Azure and AWS cloud access, and those, yeah, we can secure those things. That's already sort of completed or in work. So yeah.
Great. Quick interjection to amend my previous comment about open source tools. So not necessarily that NASA has open source tools, but the comment by our colleague on the line was mainly to indicate that there are a number of open source tools available and yet to still be developed. So apologies for the misspeak earlier. All right, moving through. Are there any mandatory standards for interoperability? For example, OML, MBSE, STEP?
So we're not going to specify those explicitly, but the interchange should be with things that are open standards. All of the above of what you mentioned, but not proprietary standards.
Uh, Next question is AI and automation for text to chip design within scope of the SBIR Ignite, this subtopic?
So I think anything for hardware design is on the table. Um, I'd say to the extent that it is applicable to the work that NASA does, and I'll allow the Ignite folks to step in if that needs to be corrected.
We'll pause to see if there is a step in. Haley?
I don't have anything to add.
Great. Will NASA provide sample data, digital artifacts, or templates?
So I think I don't have like data ready to go for the whole span of this. I think you're going to have to sort of use what's out there today. I don't know if Haley can speak to how that's usually done.
So usually it's publicly available existing data if that is a situation, or um, yeah, I'll leave it there.
Okay. Yeah. So we are trying to, part of the initiative going forward with my work is to create these public data sets of inputs and start to define schemas and things. But that work is in the future. So I would say, look at what's out there. I think the existing, deep researching tools will do a pretty good job of finding things for you to use.
This one will be for Haley. How many phase 1 and phase 2 awards? I'll rephrase. Are you able to share with the audience here the number of awards for the AI subtopic?
We do not release or really have an idea exactly of how many we will award for a given subtopic, but I can say that we are planning to make 15 across the 5 subtopics that we have published.
Great, thanks. So one person commented, so 6+ means some sort of flight testing, referring back, I do believe, to probably the TRL question. Does that sound reasonable?
So the plus aligns, yeah, to probably some kind of flight testing, but at 6, you don't have to. You have to have an appropriate environment that is similar to what you would expect to see.
And hey, that's what phase? Sorry, for my own ignorance. Is that at the end of phase
Phase
which?
2, at the end of phase 2, at the end of our SBIR investment, that's what we would like to see.
Okay, so maybe for the phase 1, you'd be looking at 3 or
Much
4.
lower. Yeah. Yeah.
Okay.
Similar to Iron Man, can a wearable interface be used to facilitate speech to text or gesture to text, from which system requirements specification are derived and system design document?
Oh, I'm so glad you asked that. That's a great question. Yes, yeah, definitely. So, I think from a philosophical standpoint, the part, the how do people express what they want to another person or a team of people or an AI system, and that is through language and through some kind of 3D input. So I think having some kind of XR or 3D input component where you're like, I want this here and this here, and then it fills it in like the Iron Man Jarvis vision. I think that would absolutely be an awesome thing to include.
Can you elaborate why not DeepSeek? Are they essentially the same COTS AI tools?
So whatever system you develop, a lot of times the prompts end up being sort of specific to the AI models used. And then we would later, plug in our API endpoints. Like if we were to deploy it internally, we would plug in our API endpoints and we cannot use that model.
Can we use NASA Luna? We are currently using this at NASA JSC.
Yeah, I think a Luna component would be interesting.
Is there a way to demo the current product as part of the submission for phase 1?
So yeah, I guess that may be more of a Haley question as far as what the phase 1 outputs are.
Yeah, so the phase 1 output is usually like a report. Some of that's negotiated. Is that I was trying to figure out if that's more of a question of like what happens in phase 2 proposals.
Haley, they're asking about demoing the product as part of the submission for phase 1.
Oh, for the phase 1 proposal. Okay.
Yeah.
Sorry. No. You would have to figure out a way to get it into the format for the documents that we request.
And maybe I'll ask a follow on. So like a link to a YouTube video showing how something works, is that like allowed in the
You can
inputs?
only submit and evaluate what is in the proposal.
Great, thank you. So kind of following on from the NASA Luna question, one commenter asked, what is NASA Luna? So just kind of a general descriptor.
So I won't go deep into it because I'm not deeply knowledgeable about it, but it is a secure collaborative data platform.
Great, thank you. Another kind of proposal related question. So does phase 2 proposal need a prototype? Can you elaborate a bit on security and reliability use cases for NASA, and what would be a good reference to look into these requirements?
So in terms of SBIR's concept for your phase 2, yes, we'd like to see a prototype, what that looks like. Maybe more of a question for Ryan.
So yeah, if you're talking about phase 2 having TRL6 hardware in a relevant environment, that's absolutely a prototype built, like a fabricated prototype, demonstrating that you're starting with the input and you're ending up with a real hardware product.
Great, thank you. So it looks like that is all of the Q&A in the chat for now. I'm gonna pull a couple questions that were received in the registration questionnaire. Apologies if some of these are a bit redundant. Is text to circuit or text to chip layout within scope?
very interested in text to circuit and chip layout. Yes.
Does NASA have specific AI ML capability, for example, object detection, classification, characterization? Interest?
So that is more along like AI for autonomy. This is AI for hardware.
Are you looking for text time compute functionality?
Say text time or test time?
Is my eyesight failing me? The latter, test time.
Okay. So if I'm getting that question right, I don't know if the asker is online. Test time compute is just letting the large language models think, and yeah, that seems like more thinking is better.
Great. And are there any security classifications for LLMs?
So that's kind of outside of my ballywick, but I know that we internally host uh, most of the frontier models.
Okay, thank you. So the final call for any Q&A from the audience before we close out. And while you're thinking of last and final questions, any last comments, Ryan, from your perspective?
I'll just reiterate that I think there's a new paradigm in engineering development, and if text to spaceship works, then text to house, text to motorcycle, text to electric vehicle, text to VR headset, all that will also work, and will have tremendous commercial value. And it's a lot of opportunity, not a lot of people thinking about it.
Great. So one question did come in. Are there sample templates available to help prepare for the phase 1 solicitation? So I'm going to volley to Haley for this question.
Yeah, if you check out the SBIR, the NASA SBIR webpage, there's a page called the Firm's Library, and there is a template for phase 1 submission on that site. So that is available to you if you'd like to use it.
Excellent. Thank you. And if there are no further questions, I think that is it for this AI subtopic Ask Me Anything session. So Ryan, thank you so much for your time. Thank you all for joining and asking your questions. And Haley, thank you as well from the Ignite initiative input. So as a reminder, do visit the Ignite website to find recordings and Q&A from all of the Ignite sessions that we will be hosting, as well as to view guidance and upcoming activity. The Ignite solicitation is now live, as Haley mentioned, and those proposals are due by July 22nd. And do join the Ignite Slack channel to stay connected and to ask follow-up questions. A big thank you again, Ryan, Haley, and all of you for joining, and we look forward to seeing your proposals. Bye.
All right. Thanks, Beth.
Thank you.